Hello, my name is Prince Kumar Trigun and I teach geography to the students of undergraduate and postgraduate. Kindly stay with me for the upcoming few minutes to understand how I teach and explain the concepts of geography. So let us study the currents of Atlantic Ocean. As we know, the Atlantic Ocean is the world's second largest ocean body on our planet Earth. It is named after the Atlas Parvat, that is the Atlas mountain located on the northeast of the Africa continent. So the ocean water body is named after this Atlas mountain, that is Atlantic Ocean. If we know about the Atlantic Ocean and its surrounding, the neighborhood, there is Africa continent on the eastern sides and Europe on the northeast side. To the west of the Atlantic Ocean, there is North American continent and South American continent. To the south of the ocean, there is Southern Ocean and the Antarctic Cycle. And similarly, to the north of the ocean, there is Arctic Ocean and the Arctic Circle. As we know that the Atlantic Ocean is rarely affected by the tsunamis because the earthquakes rarely occur in this zone, while if we talk about the Pacific Ocean, it is the most obstructed by the tsunamis and earthquakes due to the ring of fire. But if we talk about the Atlantic Ocean, it is majorly disturbed by the winds, by the currents, and the waves of the ocean. Let us study with the currents of the North Atlantic Ocean and that too with the North Equatorial Current. The North Equatorial Current originates at the coast of the western margin of the African continent. There is this country Guinea here to the western coast of Africa continent, and from here the ocean water bodies, the currents is dragged by the coming northeast trade winds that is converging at the equator. So this north equatorial current is dragged by the trade winds to the western side, and here it collides with the coast of Brazil. There is this country Brazil on the eastern margin of the South American continent. The current collides with the Brazilian coast, and the Brazil coast modified these current and divided into three streams. Yes, the northern streams enter the Gulf of Mexico near the Florida, that is USA, southeast USA. The another current that diverted towards the southern side and that moves near the coast of Brazil to the south. There is this third current, which is the subsiding down of the currents which is coming from the Guinea side and that collide to the coast of Brazil and subsided down beneath the subsurface layer of the ocean water bodies to the ocean currents, and that is the counter equatorial current that moves in the opposite direction to the north equatorial current moving on the surface. There is this counter equatorial current that is strike down by the coast of Brazil and moves downward and that flows towards the coast of Guinea again. The northern branch of the north equatorial current that moved into the Gulf of Mexico near the Florida through the channel, there is this strait. This is the Yucatan Peninsula, and there is this Caribbean islands. So there is a strait, that is Yucatan Strait near the Yucatan Peninsula, and from there the North Equatorial Current's northern branch enters the Gulf of Mexico near the Florida, and here it names Florida Current. This current is modified and supported by the coastline. If we talk about the North Equatorial Current, it was dragged by the trade winds that is coming from the northeast direction. While we talk about the Florida Current, it is dragged by the coastline of the Mexico near the Gulf of Mexico. From Florida, the current Florida current brings the fresh water from the Gulf of Mexico and moves toward the northeast coastline of the USA. Here it is known as Gulf Stream because it carries the water from the Gulf of Mexico. When the Gulf Stream reaches the northeast region of the Northern America continent, here it meets the cold current of Labrador coming from Arctic Ocean from the northern circle. This cold current and this warm current meet near the Newfoundland Island, that is, here it is Newfoundland Island, and there they give favorable condition for the growth of fog wall, which led to the growth of phytoplankton, which leads to the growth of zooplankton, and finally major fishes arrive here to feed on the zooplanktons that were grown due to the favorable condition of fog wall when the warm currents and cold currents meet at a point. Okay, so there it is a major fishing ground near the Newfoundland Island. Waters meeting at this point generate a water eddy, and this is being dragged by the westerlies that is blowing beyond 40° north and 40° south. So these water eddies, these currents after meeting being dragged by the westerlies to the eastern side, that is known as North Atlantic Drift, and here to the east coast of the Greenland there is another cold current coming from the Arctic Ocean, that is East Greenland cold current. Here it meets this North Atlantic drift, and again there is bifurcation of another current, generation of another current, which is Irminger warm current. Irminger blows to the southeast coast of Iceland. Okay, after the North Atlantic drift reaches the western coast of Europe, when this North Atlantic drift reaches the Europe continent, it bifurcates near the south of United Kingdom. This is United Kingdom. It bifurcates into two branches, the northern branch and the southern branch. The northern branch moves to the north of United Kingdom and reaches the Norway near the Scandinavian countries, where it is known as Norwegian current. The southern part of the North Atlantic drift moves towards the African coast to the western margin of the African coast and reaches near Morocco. This is Morocco, where there is Canary Island, which is a territory of Spain, and the current moves near the Canary Island, name it Canary's cold current. Now, Canary cold current moves along the coastline of Western Africa and reaches the country of Guinea, where it is known as Guinea cold current. Finally, the Guinea cold current closes the loop after meeting the north at equatorial warm current. So it becomes a circle of currents which generate a calm area, a very calm water bodies in between the North Atlantic Ocean, which we called as Sargasso Sea. Sargasso Sea. This name is derived because of a seaweed that is growing here in a very numerous manner, and that is sargassum. Sargassum seaweed named this saline calm ocean water bodies in the North Atlantic Ocean, Sargasso Sea. It is also called sea without coast because it is surrounded by the water bodies, streams, drifts and water currents. There is no coast. So this is sea without coast. If you see, there is a pattern of circular motion of currents and streams and drifts in the North Atlantic Ocean, which led to the formation of a gyre. This is known as gyre, and it is called as the subtropical clockwise. If you see, this is in a clockwise manner, clockwise rotation, so we call it gyre. It is subtropical clockwise gyre, generated due to the circular motion of currents, drifts and streams. Now let us look into the currents of South Atlantic Ocean. To the south of equator, there is southeast trade winds converging near the equator, that is blowing from southeast to the northwest direction. This trade winds drags the currents of the water bodies towards west along with them to the south of equator, and it is known as the south equatorial warm current. After this current reaches the coast of Brazil, it moves southward along the coast of Brazil, and here it is known as Brazilian warm current. This Brazilian warm current moves towards the Argentina coast, where it meets the Falkland cold current coming from the west wind drift towards the southern direction. This westward drift, which is a westerly that is blowing beyond 40° south in a similar way, there is this North Atlantic drift and this is west wind drift. So this west wind drift reaches the coast of Africa. There is Cape of Good Hope, where it strikes to the coast of South Africa and moves towards the coastline to the direction of equator northward. It is a cold current where it meets and subsided down near the equator, and this loop is completed in a anti-clockwise manner. If you look into this, this is anti-clockwise. Here it was clockwise in the north hemisphere, and here it is anti-clockwise, resulting into the formation of another gyre, which is subtropical anti-clockwise gyre.